Okay, I'm going to be doing this demonstration because my students are going to be working on drawing out reflections tomorrow in class, and I don't anticipate that they'll have a lot of difficulty doing this, but in case they do, I wanted to have a video so that I can have it uploaded to my YouTube channel so that students could refer back to it while they're doing their homework. And so that's why I'm doing this. And I'm going to be using the SFA PTM procedures for solving problems. And the first thing I'm going to do is I'm going to read the problem. Then I'm going to come up with a math practice to help me solve the problem. And then I'm going to work through my process and show my answer. So we'll go ahead here and look at the situation we're presented with, and then we'll go from there. It says here that Tanya has half of the design for the wooden pieces for her picket fence. Use the y-axis as the line of symmetry to complete her drawing. Okay, in this situation, it appears to be a real-world scenario where somebody wants a pretty design, and they want to be perfect for the pickets for their picket fence, and they've got a coordinate plane that they're using. And just to refresh my students' knowledge, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. I have heard them referred to as first quadrant, second quadrant, third quadrant, fourth quadrant. Instead of going clockwise, where we would expect to see the numbers going from least to greatest this way, we go counterclockwise, and we go from this way to this way, just to refresh that. Now, here it says that we're going to be using the y-axis as our line of symmetry. Now, there are three ways that figures can move that come to my mind right off on a coordinate plane, and one is a reflection. And you don't necessarily have to have a reflection be on a line of symmetry right on the y-axis. You can have a figure right here. You can have a, we'll say a trapezoid right here. We may want the reflection to be down here, or we may have the trapezoid here and have the reflection over here. It could be that we also could use what we call a rotation. Like when we finish this picket out, it's going to look like a picket or a rocket. It's going to have that kind of shape to it. We could rotate it or turn it like the arms of a clock, or we could also slide it. We could take this picket and we could have it here and then slide it maybe 4 units to the right or 4 units to the left, or however many units that we need to. We could even slide it not just along the x-axis, we could also slide it along the y-axis. We could also slide it along diagonally if we chose to. But here they just want us to use the y-axis as a line of symmetry. So because we are using the y-axis as a line of symmetry, we're going to have our mirror image right here, our reflection right here. And when you look in a mirror and you see a reflection, whatever is left is right, and whatever is on one side is on the other side. It's kind of opposite. It's the opposite there. You'll see when you look at your reflection, if you have a mole right below your right eye in the reflection, it's going to look like it's a mole on under the left eye of the person looking back at you. So one of the things that we'll do here is we'll pick out, and here I'm coming up with my plan now, think like a mathematician, practice number 1, make sense of a problem, and I'm going to come up with a plan, solve it step by step. I'm going to look at the coordinates at certain points. For instance, we have a point right here, and we have a point that's important right here, and we have another important point right there. And because this y-axis is our line of symmetry, whatever point we have here, the y coordinate will stay the same over here, but the x coordinate will be the opposite. For instance, let me change my color of ink just to make it something a little bit darker. For instance, here we have -2 and -6. The reflection of that, instead of having -2 over here, we're going to have +2, but the -6 is going to stay the same. And here we have -2, and we have +5, and the reflection of that point, well, it's going to be +2, and the 5 stays the same. Now here we have on the x-axis 0. 0 is its own opposite, so 0, 9. We're not going to have to bother with that. So this point is going to stay the same. Now I'm going to use thinking like a mathematician practice number 6, be precise. I'm going to be very precise when I put my points at 2, 5 here. So here's my 2. I want to go to 5, and I'm going to put that right about here. I'm trying to be very precise, very neat. Then here 2, 6, here is 2, down here is 6. So I'll be very precise and put my little point right there where it goes. Now all I have to do is just kind of make some straight lines from point to point and finish that reflection. Oh, I zoomed in too long. So let me go ahead and make that point, and then how in the world do I zoom back out? Let me see if it'll let me push down on it, it'll zoom out. Nope, that ain't gonna work. I don't know how to zoom out. Okay, here. Okay, I zoomed out, but now I need to do a little bit of erasing here. Well, I erased everything. Ain't that dandy? Okay. I'll just go ahead and put my lines. I know where everything was going to be, so I'll just go ahead and do that. All right, so I had a point here, and then I had one at 2, 5, and here's where 2, 5 is. And then I'm going to have another point here at 2, negative 6. So I'm going to go ahead and draw over there. And then from 2 on up to here. So here we have a mirror reflection of what we have here. So that is how you can make a reflection along the y-axis. So I showed my process, and I talked about how I was going to solve the problem, and I showed my answer. So according to our rubric, I would have gotten a 100% on that one. I hope that video helped. Thanks for watching.